I'd like to start off with a comment on what I've seen in the tutorials this morning. I saw many cases where students try to write code to answer a tutorial problem. And then the computer simply gives them a crazy answer and they don't understand why that is so. Now, when this happens, you don't need to feel bad. That is very common. You know, in all computer programmers' life, that happens quite often. But then you must try to find the error. You must try to find why the computer is not doing what you think it should be doing. And essentially, there are two ways that you can do that. You can use NBTutor. You can insert NBTutor. Of course, you must load NBTutor like we have it on our section files. But then you can include the NBTutor command in the cell. And then when you execute the cell, it will of course start NBTutor. And then you can run through the cell with NBTutor and check the various objects, whether the values are what you think they should be, and how the system treats those values, what the system does with those values. That's one way of doing it. Another way of doing it, which is perhaps a little bit easier to do, but which may perhaps not show you everything, is to include some print statements. And you can print, and we'll see it today, you can print from a function also. You don't need to only print from the main program, from the calling program. You can insert print statements in a function, and then when the program execution comes to that point, it will print out whatever you ask it to print. Now, for instance, when you work with functions, of course, the moment the program exits the function, those variables are no longer available. So then you cannot see what they are. But if you print them inside the function, when it gets to the print statement, at least it prints it. If it disappears after the program is now executed, it's completed the function, the variable does no longer exist, at least you can see on the screen what the variable is. And perhaps you may have expected a single value, and if you print it out, you see, oh, but it's actually an array. And sometimes, usually you can pass an array to a function, even if the function was written for a single variable. But it does depend on what you do in the function. So a common error that I've seen this morning is that students write a function where it accepts a variable as input, but then it uses that variable to generate an array in an A-range statement. If you then pass to the function an array of values, Python doesn't know what to do if it accepts as an argument in the A-range function an array of values, where normally it's expecting a single value. So that is just an example. But if you print out the things, you can see, oh, this is what happens, and it's illogical. It cannot work like that. Right. Okay, any questions on this? Then I think we concluded the previous section with this example of throwing a die, where we introduced a Boolean variable, and we've completed that, so I'm going to skip to the next example, that of a sum of random integers. So it's quite similar to the previous example that we've done. They ask us to write a program that simulates the throw of a die. So we've done that already. Then it should add the throws together until the sum is greater than 50. Let me just see what we had to do here. Here we simply had to throw the die until it lands on a 4. So it's different now that we must throw the die and see what it is, and then throw it again and see what it is, and then add them together, and carry on like that until the sum is greater than 50. And then they ask us two questions. What is the sum of the throws? Now, of course, that will not be necessarily 50. It can be, well, it cannot be 50 because 50 is not greater than 50. So if you add up to 50, you still need to carry on because you need to be larger than 50. But it cannot be anything larger than 50. It can be 51 or 52 or 53 up to 57, right? Because you can only up to 56, right? So you'd like to know what is the sum. And then also you'd like to know how many throws were needed to actually get this. The outcome here basically is, again, to understand the random rand_int function in NumPy, but also, once again, using a while loop. Right, so let's look at our code. This code is written in an NBTutor cell, so you can use NBTutor, or it will show us how this works in NBTutor. So it starts off by importing NumPy in the global namespace, and then it defines a function, some die values, and n. Now, in this case, if you look at how the function is called, here in the record 14 is the call to the function, and we see that the value 50 is passed to the function. So it means that in this question, add the throws together until the sum is greater than 50. The way the function is written, that you can actually pass it any number. You can put in 80 or 100 or whatever you'd like to pass, and that is the capital N. But since the question was asked for terminating when the sum is greater than 50, that is why in this case it passed the value of 50 to the function. So N, capital N in the record 4 then is the target that you're aiming to exceed when you are throwing the die. Okay, so in the function then, we're going to use a while loop to continually throw the die until the termination condition is being met. And the termination condition is, of course, that this must turn to be false. As long as what I've highlighted is true, the while loop will continue. And you can see inside the while loop in record 8, we throw a die. So as long as the highlighted condition is true, I'll carry on throwing a die. So because I'm doing this inside the function, and the function receives the target value of 50, I then in record 5 initialize a counter to 0. We are not going to use the counter for anything other than counting how many times we throw the die. And that is because they asked us that they asked us how many throws were needed to get to 50. If it was not for that, we didn't need a counter, then we could have left that out, because the calculation itself doesn't need a counter. And then, of course, since we're going to add all the throws, we need to have some other variable in which we collect all those throws. And that variable is die_sum in record 6. And then, of course, before you start with a while loop, that value must also be initialized to 0. You start with a 0 value. The first time you throw the die, it replaces the 0, and then as you carry on, it gets added to that. Of course, the first time you throw the die, you'll simply have 0 plus the value of the die throw, right? So these two initializations in 5 and 6 happens before the while loop is started. Now, of course, we would like to carry on until die sum is larger than 50. So the condition, remember, we must stay in the while loop when the condition, or we will stay in the while loop while the condition is true. So we must create a condition here that will be true until the sum of the die throws is larger than 50. And that's why the condition that we set is die sum smaller or equal to n. So remember now, n is the 50, so whenever as I carry on through the while loop, whenever my die sum is less than 50, it should carry on. But even if it's 50, it must carry on, because the requirement is that it should stop when the number of throws, when the die sum is larger than 50. So that's why it's smaller than or equal to n. Everybody happy with that? Okay, and then when I go into the while loop, of course, record 8 is then when I throw my die. I'm once again using the NumPy random rand_int function with arguments 1 and 7. that will generate an integer number between 1, including 1, to 7, but excluding 7. So I know since a die has got, a normal die has 6 sides, I'd like to generate a random number 1, 2, 3, 4, 5, 6. And so that's why this value is 7, because it's not included in this range of possible numbers. Right, so record 8 throws the die, and then in record 9 you can see that the die sum is now updated. So the first time it goes through the loop, this value is 0, and now I add the die throw to it, and so the first time it goes through the loop, the die sum will be equal to the first throw. But then in the second and third iterations, of course, the second and third throws will be added to the sum. And then in record 10, I also increment the counter, so I'd like to count how many times it goes through the loop, which is the same as the number of times I throw the die, because the calling program wants that. And so it will carry on in the while loop until the condition here is no longer true. In other words, until my die sum is in fact larger than n, or larger than 50 in this case. Then it will carry on with the code below the while loop. But the only code below the while loop is the return statement in record 11, so that will then return the loop counter, CNT, and the die sum to the calling program. Right, and the calling program then in record 14 calls the function with n equal to 50, and of course the counter is returned as the variable n throws, number of throws. It's just a name. And the die sum is returned in the variable name total. And then 15 and 16 simply print those values to the screen. Okay, so that's a little program here. Note here, and this was true also of the previous cell. I didn't notice that before. But what the programmer did in this case is really what we said that you should avoid. It works, but I forgot what the word was that was used. It's almost like sloppy programming, because at least we discourage this. Because inside the function, the numpy is used. So here you use numpy random rand int. But the numpy package or the numpy module is not imported in the function itself. It's imported in the global namespace. And of course, we know that the function does know what is defined in the global namespace, and because of that, it does actually work. It can actually work in the way that is here. But if you program this function as a freestanding function, and somebody calls your function, and that person hasn't defined numpy in the global namespace, this will crash because it will not know what NP is. Or the caller, the calling program may have imported numpy not as NP, but as, remember, you can import numpy as, like here, this NP is just a name. You can call it anything. You can call it PP if you want to. So if the calling program imported numpy as PP, then this will crash because it will say, but it doesn't know what's np.random. So that's why we then also recommend in the online weekly tutorials, in the semester test, in the exam, whenever you use a package inside a function, and remember you're going to use functions all the time because all the questions will be that you need to write a function that returns some other answer. So when you do that, whenever you use a package, import the package in the function itself, so that then your function is robust. Anybody can call your function, and it doesn't matter what they've imported in their global namespace, your function will actually work. Right. Okay, so let's try this. And of course, I've forgotten to actually do this. I must load NBTutor, and then also let me switch off the toolbar, and let me also make this full screen. Right, so let's go down again to our example. Which is this one here, right. So I'm executing the cell. Okay, so if I execute the first line, of course it loads NP, it loads NumPy as NP, the object NP in the global frame. Then it defines, the next line will define the function. So the function is defined as a function object, but then it jumps to the first row in the, or the first line in the main program, which then calls the function sum_die values. Okay, so if I execute that, I'm going to the function, and now in the function, in the local namespace, the only variable defined by now is capital N, which is 50. Okay, so there the counter is 0, die sum is 0, and then I go into the while loop, since the die sum value of 0 is indeed smaller than 50, so the condition in record 7 is in fact true. So in record 8, I'm about to throw the die, then I've thrown the die, and the die value, where's my cursor, is 2, so it landed on a 2. Remember, every time I execute this program, I'll get a different value in general, right? Because it's a random variable. So die sum is still 0 because it was defined as 0 in record 6. But now in record 9, it's going to be updated when I execute record 9 to the new value. And so there now die sum is 2. Counter is still 0. So in record 10, I update that if I press on the next. So counter is now 1. And so it then returned to test again whether the while loop condition now perhaps have turned into false, in which case it will exit the while loop. But of course, the die sum now is only 2, which is less than 50, so it'll stay in the while loop. So if I carry on like this, I'll just go through the while loop. So the 9 has now been, the throw now was 2 again. So I've got 2 2s in a row. And therefore, the die sum is now 4, which is, I think you can see it on the screen, but it's off in the recording window. Maybe I should just do this to show that the die sum is 4. And then it's about to update the counter. So the counter here is still 1, but if I press on next, it changed to 2. And then since the die sum is now 4, it's less than 50, it will carry on in the loop. I think you get the drift. Are there any questions on the while loop here? Because I'd like to now conclude this. I'm not going to go through this until we get to 50. Everybody happy? Can I jump to the end? So I click on last line. And so now it's exited the function. So all the variables in the local namespace no longer exist. But note that in record 14, I've now defined 2 new variables, n throws, which is the number of throws, which is CNT from the function, and total. And so I see that n throws is 18. It means that I had to throw the die 18 times before I got to a total that was larger than 50. And what was that total? Oh, the total was 51 in this case. So if you run this again, the total may be different and the number of throws may also be different. Because every time I execute record 8, I will get a different value from before, right? And of course, by now this would have been printed to the screen. And so there you can see the number of throws, 18. The sum of all the throws is 51. Any questions on this? Yes? Okay, the n throws. I didn't catch the question. What about n throws? How did it get its value? Okay, so the question is, how did n throws got its value? Okay, let me do this just to get rid of the NB tutor. Remember that the function here calculates 2 variables. Well, it calculates more than 2 variables, but it has 2 variables that it passes to the calling program, which is whatever is behind the return statement, or whatever is in the return statement, whatever follows return in the return statement is the objects that are returned to the calling program. Now, those objects can be single numbers, it can be It can be any object. It can be a function. It can be whatever you can define as an object in Python. But in this case, it's two numbers. And so the first number is CNT, which is the loop counter. And the second one is die sum. It's the sum of the die throws. So in the calling program, you need to then have of course you can in the calling program, and that's many of the examples are actually like this, where you just have print and then the call to the function. So the call to the function is nested in a print statement. And if you do that here, it will print 18,51. But quite often, you use a function not just to print values. You use a function because you want to use it someplace else. And in that case, it's actually useful to write the return from the function into variable names. So since I'm receiving two values, two single numbers, it's sensible to then put here two numbers. But there's nothing that says that this name must be the same as that name. I can give it any name. And likewise, this name also doesn't need to be the same as that name. And the same is actually true for this 50. Okay, here I've used a number, but I could have used a name here also. I could have called it K, and as long as K was defined earlier. So this value here also doesn't need to have the same name as what is there. If I want to use the format where I say variable equals 50, then that variable must be n, capital N. But if I just pass a value or just a variable name, it does not need to be capital N. It can be any name. Right now, another way that I could have done here is I could have just written a single name, and it'll work. But then that single name will be a tuple containing the two answers. And then I can, if I want the first one, I can say the tuple name, whatever name I've used, square brackets naught. I'm just using indexing to then extract the first value. And if I want the second value, I will have the tuple name square brackets 1. Right. Okay, I hope that answers your question. It's an important question, important to understand this, yes. Will it still work if the two variables are? Sorry, no, I don't get that. Let me just get...